Hi, my name is Nicole Gavin. I'm a current high school senior. I plan on majoring in biology with hopes to go on to medical school and become a doctor. Today I'm going to be teaching you some basic genetics and how inheritance works a little bit using dominant and recessive genes in eye color. Jill and Pat want to have a child, and they were wondering what eye color the child would have because Jill has brown eyes and Pat has blue eyes. Brown eyes are dominant to blue eyes, so if a brown-eyed allele is present in the combination, brown eye will be expressed. Alleles are expressed using letters. So for recessive alleles, such as blue eyes, we would use the letter little b. Since it is recessive and it's being expressed, Pat's genotype has to be little b, little b. Jill, however, because she has the dominant trait, could be big B, or big B, little b. In this example, we're going to say that she is big B, little b. And as I said, their phenotypes are what they physically express. So since Jill has brown eyes, her phenotype is brown. And since Pat has blue eyes, he has blue. Now let's move over to the Punnet square. Each one of their genotypes produces a gamete. When those gametes are put together, they create a zygote with a combination of alleles. Pat's alleles are the yellows, and Jill's alleles are the pink. Pat has no choice other than to give little b, little b. Jill can either give a big B or a little b. They move like this. So we have 4 combinations of alleles, which give us 4 different outcomes of possible children they could have. The genotype ratios are there are 2 that have big B, little b, and 2 that have little b, little b. So it's a ratio of 1 to 1, big B, little b to little b, and that is a 50% chance for each. The phenotypical ratio, since there is this one dominant allele, these 2 children will have brown eyes, and since there is the absence of a dominant allele, the recessive trait will show through, so these 2 children will have blue eyes. Therefore, the phenotypic ratio will be 1 to 1, brown to blue, and there's a 50% chance for each. So that's how you know Jill and Pat have a 50% chance of having a blue-eyed child and a 50% chance of having a brown-eyed child. Isn't it cool that we can predict the eye color of someone who hasn't even been born yet? We can use the same technique to predict for other traits and even look for the emergence of genetic disease. Again, my name is Nicole. Thanks so much for watching.